Hello, everybody. My name is Brian Mojica, and today's assignment is Use of IT in Comparative Effectiveness. Our objectives today is to complete a mini comparative effectiveness study, and we would do that by identifying two patients as match controls for the indicated cases. We would select controls randomly, and we would use the lowest random numbers. We would also develop a Kaplan-Meier survival plot of the patients with no falls. Here is the sample data that was provided to us. As you can see, patient 1 and 3 received intervention, which will be our case studies. In the range of age, it is between 60 and 84 years old. On the very right column, you can see it says random number, and that would normally be a value of some kind of medical measurement since we're in the healthcare field, and it would be like heart rate, blood pressure, glucose levels, etc. So with the data, we need to figure out the standard deviation. The standard deviation is here, as the formula shows, and once you put it into an Excel spreadsheet, you can figure it out um, by using the equal function and put STD um, and use the S. S is for the sample. So once you do your calculations, you can see for case 1, which would be with patient ID 1, is one standard deviation is 8.89. So that means for case 1, you would take the age that they have, which is 65, and then plus and minus 8.89. So the minimum would be 56.11 and the maximum would be 73.89. So basically, it's one standard deviation between from that age. For case 2, the same thing, but in this case, the age is 84, so you do plus or minus 8.89 with that, and that would be a minimum of 75.11 and a maximum of 92.89. And if you compare it with the other case studies or patient IDs, patients 2, 8, and 9 are within that range with case 1, while patient IDs 4, 5, 6, 7 are in the range for case 2, as you can see there. I have color coded and which showing yellow is the case studies and red is the ones that are matched to patient 1 or case study 1, and the blue is patient 2 matched to patient 3. So on the right, with the random numbers, we said we're going to take the lowest random numbers or measures, and that would be considered our controls. Since we have two of them, so from the blue and the red columns, we would take the two lowest numbers. So for the blue, you can see there's 0.7, 0.87, 0.72, and 0.86. Out of the four of them, two of them would be the lowest, which is zero point 0.7 and 0.72. For the red, we have 0.85, 0.16, and 0.17, and the lowest two would be 0.16 and 0.17. Okay, for the Kaplan-Meier plot data, so we would do it with the cases, and it's to determine the ratio and probability of risk of patients falling and not falling, which were patient 1 and 3. And you can see the data here. For example, in months 1, 2 were at risk, 0 had their first fall, 2 had no falls, so the probability was with 1, which means there was 100% of never fallen. So we would do the same thing, but it would be with the controls. So in this case, it would to determine the ratio and probability of risk of patients falling and not falling for the controls. 4 controls were indicated, and in this example, uh, the first one, 4 were at risk, 0 with the first fall, 4 with no falls. The probability is 1, which is 100% has never fallen. And once you graph those two with the cases and controls, it looks like this. Next is our analysis of event trees. So we would need to determine the probabilities of all the possible outcomes of an event. And this also provides a visualization on the analysis that we're going to cover. So first thing we need to know is the different terminology and just understanding the tree itself. So first you can see in yellow is called the node, and those are pivotal events. In red, it's the probability of an event to occur. So in this case, it was 0.85. So 85% chance that this probability, this event would occur. And you can see the next one is the positive event, which is basically saying the blood pressure will be less than 90. So that's what the event that they're trying to figure out. And then the outcome, which is the very bottom in green, is an outcome of a possible event, which is how long it took. And in this case, it was 4 days. So the questions are, what is the expected length of stay for each of the clinicians? What is the expected length of stay for Dr. Smith if he were to take care of patients of Dr. Jones? What is the expected length of stay for Dr. Jones if he were to take care of patients of Dr. Smith? You can see on the top says previous MI is 0.25 and then CHF is 0.15. So 0.25 times 0.15, and you can see the outcome is at the very top, which is 4.5 days. And you can see that's where we get that. So we will do that for each various branch or different types of outcomes. And the calculation shows here. So for Dr. Smith's practice, the total amount of days would be 3.64. Now for Dr. Jones, we would do the same thing. And you can see here's the calculations, and for his total length of stay would be 4.76. Now, if we take Dr. Smith seeing Dr. Jones' patient's calculation, we would do the same thing, and we would just switch it around. But now the total length of stay for this one would be 4.3 days. And if we did Dr. Jones seeing Dr. Smith's patients, it would come out to 3.74 days. So in conclusion, so the question again, what is the expected length of stay for each of the clinicians? And as we did our calculation, Dr. Jones equals 4.76 days. Dr. Smith is 3.64 days. Second question is, what is the expected length of stay for Dr. Smith if he were to take care of patients of Dr. Jones? And we found out it was 4.30 days. Third question is, what is the expected length of stay for Dr. Jones if he were to take care of patients of Dr. Smith? And we calculated to be 3.74 days.